Good morning, students. Here in this class we study the 9th standard geometry, unit 2, Euclid geometry. In Euclid geometry, we are already studying 8th geometry first chapter, Indian mathematics in brief explanation. We are studying 8th standard first unit. In this first unit, we already know the Indian mathematicians. Indian mathematicians, greatest mathematicians like Srinivas Ramanujan and Shakuntala Devi, Bhaskaracharya, first and second, and Aryabhata, Mahaviracharya, etc. All the great mathematicians in India. We already studied our 8th standard first unit. In this class, in Euclid geometry, first we are know the meaning of geometry. What is the meaning of geometry? Geometry word contains derived from two Greek words. First is zeo and second one is metron. The zeo means earth. Geometry word derived from the two Greek words. First one is zeo means earth. Metron means measurement. It is the Greek words. Zeo and metron are two Greek words. The meaning is earth measurement. It is called as geometry. Then the development of geometry, how it is developed in Indians and other countries in ancient civilization. Geometry had originated from ancient civilization in this type, originated from the need for measuring of land. How it is developed? It is geometry to originate from the need for measuring of land. Then the branch of mathematics was studied in various civilizations. Like civilization B, it is Egypt, Babylonia, China, India, Greece, Indica, etc. In this civilization, geometry is developed. The people of this civilization faced several practical problems which originated with geometry. The development of geometry in various ways. Example, in Egypt, Egyptians construct the pyramids. He used the geometry in construct the pyramids. Then in India, geometry is used in Indian subcontinent. The excavation of Harappa and Mohenjo-daro, etc. Civilizations show that the Indus Valley civilization made extensive use of geometry in Harappa Mohenjo-daro civilization. Then Shulva Sutras. May contain using geometry. Then in this way. In Shulva Sutras contain manual geometric construction. Shulva Sutra, the ancient civilization of India, contain manual geometric constructions. These examples show that in ancient civilization, geometry is developed and applied for everywhere in the world. But this was not appearing in the unsystematic manner. It is in unsystematic manner. Then what civilization can use correct method for geometry? First for Egyptians used geometry mostly for practical purposes, but not development of geometry. Egyptians used it for geometry for practical purpose only, but not development of geometry. Then Greeks were interested in establishing the truth of the statements. Truth of the statement. They discovered using deductive reasoning for symmetry. Then a Greek famous mathematician called Thales is created with giving the first known. The proof was the statement that a circle is bisected by its diameter. Proof was the statement that a circle is given a statement as the proof. It is the statement that a circle is bisected by its diameter. It is the famous proof of the Thales, a Greek mathematician. Then next, one of the Thales' most famous pupils was Pythagoras. One of the Thales' most pupils was Pythagoras. Pythagoras and its groups achieved some geometric properties developed. These are, he discovered many geometric properties and developed the theory of geometry to a great extent. He developed many geometrical properties and developed the theory of geometry for Pythagoras and his group. Developers. Then at the same time, Euclid is a teacher of mathematics at Alexandria. Euclid at the same time, is Pythagoras and his group in his time. Euclid is a teacher of mathematics at Alexandria in Egypt. He collected all the known work for ancient mathematicians' works and arranged it in famous trade is called elements. The elements. He collected all known work for ancient mathematicians and arranged it in famous treatise called elements. The book written was the Euclid is called Elements. He divided the elements into 30 chapters, each called a book. These books influence the whole world understand the geometry for generations to come. This work is Euclid established. Then Euclid is called father of geometry. Euclid is called father of geometry is important point. Then in this chapter we shall discuss about Euclid's approach to geometry and we shall try to link with it the present day geometry. Then we shall study Euclid definitions and postulates. First we will Euclid in his definition. First we will known as axioms and postulates. First, the definition of axioms is the general statements which are accepted without questions, which are applicable to all branches of science or commonly called as axioms. These definition of axioms and postulates are important and we know this and return this and memorize it. The general statements are which are accepted without question, which are applicable to all branches, which are applicable to all branches of science are commonly called as axioms. Then postulates, the statements which are applicable for, which are particular to geometry, which are applicable to particular for geometry only and accepted without questions, then it is called as postulates. Then again, the statement, postulate definition is the statements which are applicable only particular to geometry, accepted without any questions. These are called postulates. The difference between axioms and postulates is axioms are applicable to all Then postulates which are applicable only particular to geometry, accepted without any questions. These are called postulates. The difference of axioms and postulate is, we have known this. Then axioms and postulates are assumptions which are obvious universal truth. They are not true. They are not true. Then we discuss about first part, the definition of Euclid definitions. We shall study first Euclid definitions. The first definition is a point is that which has no path. A point is that which has no path. Example, there is a point A. It is a point is that which has no path. Then second one definition is a line is breadth plus length. Example, a line will be drawn. P and Q. A line is, definition is, a line is breadth plus length. A line having only length, not breadth. Then third one definition is the ends of a line are points. The ends of a line are points. We will draw the line AB. Draw a line AB. Then the ends of a line is having 2 points. One is A and another one is B. End point is having the end line having points. Then fourth one definition is a straight line is a line which lies evenly with the points on itself. Read as again, a straight line is a line which lies evenly with the points on itself. Example, we draw a line. We draw one line. A and B. Definition is a straight line is a line which lies evenly with the points. A line having more many points is the meaning of fourth definition. The fourth definition meaning is a straight line is a line which lies evenly with the points on itself. Then fifth one is a surface is that which has length and breadth only. A surface is that fifth one definition is a surface is that which has length and breadth only. It is a square. Example, it is a square. It having length and it is a one surface having one surface. It having length and breadth. Example, square. Length and breadth. A surface is that which has having length and breadth only, having two regions. Then the edges of a surface are lines. The edges of a surface are lines. the edges of a edges. It is AB is one edge, BC is another, and CD is third side. Then DA on fourth side of the square. The edges of the square is four lines. One is AB, another one is BC, third one is CD, and last one is DA. The edges of the surface are only lines. Then a plane surface is a surface which lies evenly with the straight lines on itself. Again, read this. A plane surface is a surface which lies evenly with the straight line itself. The surface having only straight lines only. Surface having only straight lines. Example. Surface having only edges, having only straight lines, not lines. Euclid's axioms. First one axiom is things which are equal to the same thing are equal to one another. Again, things which are equal to one another, the same thing. Things which are equal to the same thing are equal to one another. Its meaning is A is equal to B, and again A is equal to C. Then therefore A is equal to C and A is equal to C and B is equal to C. Therefore A is equal to B is equal to C. For example, we see the three rectangles is there. A is one rectangle and B is another rectangle and C is another rectangle. Its statement is show that things which are equal to the same thing. These are three rectangles are equal length and equal breadth. A is equal to B. A is equal to B. First one is A rectangle equals to B rectangle. Then A rectangle is equal to C rectangle. Then all three rectangles are equal. All three rectangles are equal. Three rectangles, A is equal to B, B is equal to C. A is equal to C, A is equal to C and B is equal to C. Then all three are equal length and equal breadth, all are same. A is equal to B and B is equal to C. Then the second axiom is if equals are added to equals, the wholes are equal. Then again, if equals are added to equals, the whole are equal. Then example is then we cut the two triangles for 1/3 fractions. The two cut triangles are equal. Then equals are added to equals. It is one triangle with another cut triangle. We added to these triangles for equal part. We added to these triangles to equal part. Then it is equal. Then two cut circles here. Then we add two circles to two equal parts. In this circle to one equal part. Another circle to another equal part. Then two cut circles to add equal parts. Then two circles are same. The second axis shows. Then the equals are added to equals. The holes are equal. The cut circles are same in two circles. We added two pieces. So the circle are same. Then the third statement is that if equals are subtracted from equals, the remainders are equal. Again, if equals are subtracted from equals, the remainders are same. Here, we are having two rectangles, A and B, two rectangles. Those are equals. Rectangles, those are equals, length and equal width, those are equal. Then we subtract from equals, subtract from equal part. We subtract from two rectangle for same length. We subtract it. Then the remainder are equal. It is statement given. The remainders are, this is one remainder, this is another remainder. Both are equal. It has given in the third statement. Understand this? The equals are, it is A and C, two rectangles. We are subtracted same length and breadth. Then remaining length and breadth of rectangles are both remaining are same. The third statement meaning is this. Then fourth one is things which are coincide with one another are equal to one another. Things which coincide with one another are equal to one another. Things, these are two squares. These are two squares which coincide with one another. Two squares coincide with one another. We see are equal to one another. Both are equal length and breadth in square. All sides are equal. Then we see that things which are coincide with one another are equal to one another. Then the whole is, fifth one is, the whole is greater than the part. The whole is greater than the part. Then if you have one circle, then whole circle is, we see whole circle is there. Then we cut the circle to in this type. We cut the circle to this type. Then we compare whole circle and cut circle. We compare to these. Then whole circle is there, cutting part is there. Then whole is greater than the part. Whole is, this is greater than the part. It is greater, it is small. The meaning of fifth one is, the whole is greater than the part. Then sixth one. Then sixth one, things which are double of the same things. Things which are double of the same things are equal to one another. Things which are double of the same things are equal to one another. Three rectangles we show here. One is A, another one is B, another one is C. Those are equal length and breadth. We combine those A and B. We combine both A and B, which are double same things, are equal to one another. We are double the two rectangles. Double this. Then another one is this. Another one is C. Another one is C. Then we compare the double part and single part C. Double part is A and B and single part is C. Then the length of first one double thing and length and breadth of single thing, or we compare this one are same, because all three length and breadth are same. The meaning of the sixth is things which are double of the same things. These are the same things are equal to one another. Then last one, seventh one is things which are halves of the same things are equal to one another. Things which are halves of the same things are equal to one another. Things which are half to things which are equal to one another. Last one is things which are halves of the same things are equal to one another. Take one circle is divided to two equal parts. Shown here. One circle, whole circle is divided into two parts. Then the two parts of the same thing, same circle we join here. Then we compare the joining equivalent whole circle. Things which are halves of the same things. Same circle, two parts. The same things are equal to same things. Two things is there. Those are equals. Because the cut pieces are from same circle we cut it. Then those are equal parts are equal. Then the meaning of seventh one is things which are halves of the same things are equal to one another. And first concept of Euclid says a straight line may be drawn from any one point to any other point. A straight line may be drawn from any one point to any other point. Then see here example. One point is A, another point is B. We will draw straight line maybe from one point A to any another point B. Then one straight line will be formed. One point to another. We will join it 2 points from one to any another point. A straight line may be drawn from any one point to any another point. Then second one is a terminated line can be produced infinitely. Once again, a terminated line can be produced infinitely. Example, we draw one line. P and Q. One line we draw. A terminated line can be produced infinitely. From a point P and Q, we draw the external line from P on electric side, Q on electric side. We will draw again from a point of view Q from the other one side, another point P. We will draw again the number line, extend it. Then it means the terminated line can be produced infinitely from the 2 points. From on this Q side and this P side, we produce infinitely, we draw the line. Then third one is a circle can be drawn with any center and any radius. A circle can be drawn with any center and any radius. We will draw one circle. Center of the point is O. Then we know that from the center of the circle and any point of the circumference of the circle, we join it, taken A point. OA is called radius of the circle. Any circle can be drawn from one center, any center. Then we have one radius. We turn this from point of view. We again the place changes the radius. Then fourth one is all right angles are equal to one another. All right angles are equal to one another. Example, we draw right angles. All are right angles. Then all right angles are equal to one another. Same length, same angle, having same angle, have the right angles are equal to one another. Then fifth one is a straight line. It is a straight line falling on two straight lines. If a straight line falling on two straight lines makes the interior angle, on the same side of it taken together less than two right angles if produced indefinitely. Mean on that side on which the sum of the angles is less than two right angles. Understand this statement. If two straight lines are there, then one straight line is falling on the two straight lines, cutting the two straight lines. The interior angles on the same side of it taken together and less than two right angles if produced indifferently meet on that side of which the sum of the angles is less than two right angles. Please show this the picture. If two lines are there, its meaning is two straight lines two straight lines straight lines are there. PQ and RS. PQ, RS, two straight lines. Then, if a straight line falling on two straight lines. If a straight line was falling on the two straight lines AB, the interior angles here, interior angles on the same side, interior angles is same side, if we take them together less than two right angles, it's important, it is less than right angles, it means that less than 90 degree. It becomes, interior angles becomes less than 90 degree. If produced infinitely, if produced two lines infinitely, if produced two lines infinitely, if produced two lines infinitely, we produce to the two straight lines infinitely from the points of view from P and R. We see here the two lines extended forward, then meet on that side, meet on that side. We extend this from a point, then the two lines are meet at one point, because two straight lines, one straight line falling on two straight lines, then one side angles are less than 90 degrees, then we extended the straight lines, then it will meet at one point, then which the sum of angle is less than two right angles. Sum of angles is less than two right angles. Then Euclid sixth postulate is the equivalent versions of Euclid's fifth postulates are, first one is fifth postulate. This is called as equivalent versions of Euclid's fifth postulates. Then first one is for every line L and for every point P not lying on L, there exists a unique line in passing through P and parallel to L. Then again for every line L and for every point P not lying on L, there exists a unique line in passing through parallel to the same line. Its meaning is one line, two straight lines, L and M. It is M. Then again another one is L. Two straight lines. Then one is L, and for every point P not lying on L, this point P not lying on L. Cross lines, we will extend it. Then again the cross line is there. Then M1, L9 is here. Then 2 for every line L, and for every point P not lying on L. Here. Then there exists unitary line. There exists a unitary line in passing through P. Passing through P and parallel to L. Then two distinct intersecting lines cannot be parallel to the two distinct intersecting lines cannot be parallel to L. The result is the two intersecting, the two distinct intersecting lines, the two intersecting distinct lines cannot be parallel. Then here for every line L and for every point P not lying on L, not lying on L. Then in passing through P, these two lines passing over the point P on another straight line, then parallel to L. Then the two distinct intersecting lines cannot be parallel to the same line. The two intersecting two lines cannot be parallel to the same line. Then the result, we conclude that the two intersecting distinct lines cannot be parallel. Result is two intersecting distinct lines cannot be parallel. These are Euclid's definitions and axioms and postulates we studied in this class are important for your exam point. Then we remember and written this Euclid axioms and definitions and postulates of Euclid's. We will remember and applicable to our daily life. We will see here in the Euclid geometry, point, line, angles, we will and straight lines, in circle, the radius. We show here the statements. We are examples we see in this. I will give it the definitions, answers, and postulates. You will understand and return and remember this. The next class we will discuss about the definition, axes and postulates for the exercise problems, exercise 2.1, and for this next class I will discuss the next class for this Euclid's postulates for examples and exercise problems. Thank you.